Hello everyone, welcome to my session on build and deploy containerized apps with Azure Kubernetes services and Azure Cosmos DB. I'm Sandeep S. Nair. I'm a senior program manager in the Cosmos DB team. I've been in Microsoft for about 9 months. I came here after 22 years in a smaller organization where I started as a developer. I led multiple teams, build database applications. I worked for startups, I worked for the biggies, and here I am. You can find me on LinkedIn, and you can find some reports that I have on GitHub too. So let's get started. So today's agenda is we look at what are the challenges that businesses are facing today, and we'll talk about the solution, and then I'll walk you through a small sample that we have built on how the problem can be mitigated. As we all know that today it's a fast evolving, ever-changing world. Customers expect things fast. They want things to be tailored to their requirements and also delivered quickly. We do not have time or luxury to design stuff, develop something, and then wait. So we need to be very fast. We need to be very swift in our innovation. And for this swift innovation, we need things to happen fast. So for doing things fast, what are the challenges that today's developers face? I can think of two problems. One, they have to deal with monolithic architectures. What I mean by monolithic architectures is an application where everything is built into itself, where every piece is kind of connected with other piece. So if you want to change something, you need to change a lot. If you want to change a small thing, you need to test the whole thing. This makes the whole process very, very time consuming and expensive. Making changes, being swift in your, and having innovation is not possible with monolithic architecture. So we need to change that. That's one problem. Second problem, compatibility. All developers have heard this. It works on my machine. Why does that happen? Because your environment, the development environment, is different from the production environment. The development environment is different from the staging environment. The staging environment is different from the production environment. You're dealing with a series of environments, each environment having its own set of nuances. People spend days and hours figuring out what the problem is because they just can't figure out the compatibility issue there. So there has to be some way where we can get rid of these compatibility issues. Modern application development is the answer to both of these solutions. What are modern applications? Modern applications are applications that are cloud native in nature. And when I mean cloud native, what I mean is they are designed for the cloud, they reside on the cloud, and they are made to utilize the cloud in the full way. So you get maximum return on investment. Second, they're built using microservices. What are microservices? Microservices are small building blocks. They are independent applications that run, and they have a contract, and the whole application is made of a ton of these microservices who are interacting with each other. Think of them like the Lego blocks. You have a Lego block. Each block has got its independent role, and then these blocks connect with each other and build you can make a palace out of it, or you can make a building out of it, or maybe you can make a truck out of it. The block by itself is not worried about the whole application. It's only responsible for its own job. Now that we understand that monolithic applications are not good, we need to have microservices. Next comes, how do we build these applications? So there are three concepts that come into play when we talk about modern applications. One is called containerization. Containerization is basically take your small microservice application, package everything into a container, the dependencies, the file libraries and everything, so that you have one container that you can ship out. And so that's called containerization, and that Docker is the standard for containerization today. Next, now that we have containerized our application and we have these containers ready, how do we make sure that they work on production, they scale in production? If one container fails, how do we make sure that a new container is spawned? So how do you take care of the management or orchestration of these containers? And that's where container orchestration comes into play, which is to take care of containers and manage its life cycle. And Kubernetes is the default standard that we have today. So we'll use Docker, we'll use Kubernetes. And now that you have a container and orchestration, your code, which is built, has to become a containerized app. There has to be some way of continuously delivering into a containerized format. And that's where continuous delivery or CI/CD pipelines come into picture. We will see how we will use a container, a CI/CD pipeline, or how we deliver a container, how the containers can be then deployed on Azure using AKS, and then we'll go through that in a demo later on. So when we talk about deployment of these containers or these services on Azure, we talk about two ways that you could do it. We have the ARM templates, and we have Bicep, which is a simplified format of ARM. It is very easy to use, and it can be used to make sure that your services are all deployed properly on production. Then we have ASO. ASO, or Azure Service Objects, are basically custom resource definitions that are built into the Kubernetes itself. So if you already have your AKS, if you already running all your jobs through Kubernetes, and you want to manage your resources also from Kubernetes, then instead of Bicep, you could just use ASO and build all your resources directly from Kubernetes itself. In this demo, we'll look at Bicep, and you could look at ASO later on. The sample that I'm going to share also has got ASO code in it. This is the path of my GitHub repo. You could go and look this up in GitHub. It is fairly well documented, and you would find most everything required there. But anyway, let me walk you through that in this presentation. So what we're going to look at is application. We have taken a simple to-do application that we have for Cosmos DB, and we are going to deploy that using the concepts that I mentioned. So first thing that we do is we write our application in Visual Studio. It could be Visual Studio or Visual Studio Code. Then we convert it into a Docker image and put it to Azure Container Registry. So now this container, what we are going to do is our application through a Docker push goes and sits inside Azure Container Registry. And Azure Container Registry is a service where you can host your container application images, and which can be later pulled and used by other services. Apart from that, what our deployment code is going to do is, one, it's going to deploy a key vault. A key vault is an Azure service that's supposed to store sensitive information like certificates, passwords, etc., so that you don't have to share them or in clear text or deploy it as in clear text. Second thing it's going to deploy is an Azure Kubernetes cluster. And inside the Azure Kubernetes cluster, it's making sure that it's going to be done inside a subnet. So basically, the idea here is that we are going to put all our services inside a subnet, and so that the traffic is limited inside the subnet, and we are not having service going on the internet. We are going to deploy some pods. These pods are the containers that we created here are going to, containers are going to be the templates, and these containers images will be used here to deploy pods, which are our working nodes or working objects, right? We can decide how many pods you want to do based on the configuration that we provide. To make sure that our pods are able to connect with Cosmos DB, we are going to deploy a service endpoint, and this service endpoint is then going to talk to Cosmos DB. So our applications that's residing inside this pod is going to use the service endpoint and then talk to Cosmos DB. We are going to have an ingress service in Azure Kubernetes service, which is basically to provide a load balancer as well as to provide outload looking IP. Then we also are going to use a secret store CSI, which is going to help this Azure Kubernetes cluster to talk to Key Vault and read our secrets. Finally, we also have a log analytics. So any errors that you see here, any kind of logging that you hear, if you want, you could send it to log analytics. It's an optional component, so I put it as a dotted line. But yeah, it's a good practice to have log analytics so that whenever you are running a production workload, you can use log analytics to look at all your issues or bugs or errors that you're showing up on the portal or on your application. So now that you understand the application, let's go and see this in action. What I'm going to do is I have like I said, this is the repo that I have. In this repo, you have basically, I have created two versions of it. One is the ASO version of it here, and then the bicep version. Let's go to the bicep version and see what is there. So basically, we have the modules here, which has got basically the definitions for the various resources that we are going to build out here. And then we have main.bicep, which has basically the main code for running the bicep file, which has got all the details of our deployment. We have a param.json, which is basically some parameters that we are going to provide. And we have got some YAML template files, which will help you build the YAML files as we move forward. So what we're doing here is basically we are initializing our parameters to the param.json. Basically, we provide information on our resource group, the account name for our Cosmos account, and the name that we want to use for our container registry. One thing that I would want to call out here is make sure that you go through this link and make sure that understand the naming restrictions and provide the names properly. If you don't do that, what happens is when you run the deployment, it will run for some time, and then it will come back and complain about the name not being compatible, and you will have to run it again. So just go through this first, helps save some time. Next, we create a name, give a name for our deployment. We select our location, and then we run this az deployment sub create command, and it basically runs for a few minutes. And after a few minutes, you would see a succeeded status here. Also, if you go back to your resource group, you would be able to, you could see the succeeded here too. Okay. Now, once your deployment or bicep deployment is complete, there are some few more commands to run. Basically, we need to link the ACR with our AKS, which is what step number 5 does. Next, in step number 6, we basically connect to the AKS cluster so that we can run some commands on the AKS cluster here. And then next step is basically connecting our AKS cluster to our key vault. And that's what the step number 7 does. Once that, it on step number 8, and then we do our application development and application push to our ACR in step number 9. You could do it through Visual Studio Code or Visual Studio, or even command line, depending on your skills. Once the application has been converted into a Docker image and has been pushed to the ACR, we prepare the final deployment, which is the pod deployment YAML file here. Here we provide the name for our ACR. We give the name for our application and its version, and here we give the information about our key vault. We use the kubectl apply command to create our pods, and once the pods are created, we need to expose those pods to the external service, and that's what we do through the kubectl get services here. So we are able to get the public IP of our kubectl ingress service that we have created. And from this service, once you have it, you will be able to run the command and you will see our application running fine here. So let's go back to Cosmos DB and see there is this Cosmos DB database here. There's the AKS cluster that we have created here. So when you go to this Cosmos DB, you would see that it has created the container, the database, and Kubernetes also. Once you have your Kubernetes service deployed, you will be able to see all your pods running here. You will be able to see the deployment that we did, the pods that we are running here. So these are the 2 pods that our service deployed. And here we will be able to see our services or the ingress service that we built and the public IP that it got created. So you can see that the to-do app that we created here has got a private IP here and a public IP that got created. And when you click this IP, it goes to our public application. So that's all I wanted to show. basically the idea here is that if you use Bicep, if you use AKS, if you use Dockers and containers, what we could do is we could make our application development pretty smooth. We could make them modular in nature and basically make sure that we are able to evolve our software fast. We are not having dependency trees where any small change makes big impact and has to be tested. The whole application has to be tested. Come design applications using contracts where each microservice has got a contract, and as long as it's adhering to the contract and doing its job, everything should be working fine. So by doing that, each of us can focus on microservices, and as long as each microservice is doing its job, your application will work fine. The best part is if one microservice, if you want to change, you can just replace one microservice and just retain your whole application as it is. So as technology evolves, as things change, you can keep changing your microservices, and you really don't have to change the whole thing when things have to evolve. So I hope you like my presentation. Thank you very much. Bye-bye.